HFCA today. Normally I spend my time employed by Air Liquide, looking on business development and looking at interface with our hydrogen energy team. But today I want to talk about something in terms of UK HFCA presentation with regard to fuel cell developments, but also work that's ongoing with the BCJ, which is the British Compressed Gas Association, around standards and installations. So just to give an overview in terms of where UK HFCA came from, it actually is the amalgam of Fuel Cells UK and UK Hydrogen Association. And the aim was to take two associations with parallel interests to actually to develop an actual weight in the marketplace, which gave greater influence, was improved credibility and provided more of a one-stop shop for government and for other bodies to go to, enhanced the positioning within those areas, and was more cost-effective and able to do more things. So there's been more promotions, like there was presentations at Portcullis House last year, and there's a number of events ongoing, and giving a greater clarity really in terms of, for the UK industry, where the vision was going for the business. The membership is made up of a cross-section of academics, gas suppliers, technology providers, technology developers. And effectively look at it, it's a who's who of who's in the industry at the moment in terms of the UK. So positioning really is, the aim is to start to take it acceleration of the commercialization of fuel cells and hydrogen energy in the UK. The association really provides an authoritative viewpoint, so it's providing commentary in terms of potential new legislation, energy market reform, various other initiatives that are taken by government, and provides a point where there's a viewpoint on research development and where the priorities are, whilst the market's still in transition phase, for government and other funding agencies such as Technology Strategy Board. The areas covered are all fuel cell types and applications, covering the complete fuel cell chain from research through material science to integration and distribution, covers hydrogen production and storage, infrastructure, and any other issues around the delivery, storage and use of associated fuel cells. So, why fuel cells? And Dan's kind of given some of the background in terms of where things are going, but in terms of fuel cells really provide a key opportunity to decarbonise a large range of applications. We've talked about power and heat applications, the transport applications there and the portable ones, and essentially they are units which are firstly safe, they're very, very efficient, they're clean in terms of the fact there's very little in terms of emissions around that. The reliability now is being shown to be demonstrated with long running times, and the availability is increasing all the time, and they're becoming far more cost competitive. So we're definitely in that transition where we've seen they are funded projects through to actually being commercially competitive. And they can operate on a range of fuels as well as hydrogen. There are cells working on natural gas, methanol, ethanol, methane and other gases. So why do people look to use hydrogen? Hydrogen itself can offer a zero carbon footprint depending on the method of production. And I'll talk a little bit about what the differences are, because people do talk about the source of hydrogen and the importance, and I'll show the impacts of where that can be. And there's a variety of methods. Hydrogen, currently the largest amounts of hydrogen are produced by steam methane reforming, mainly for diesel production, but there's a lot of clean electrolysis-based technologies and that we will see more of in terms of some of the later presentations. And hydrogen can be available as a byproduct stream as well. One of the production sources in the UK at the moment is taking from a byproduct from chlorine production. And the product itself is safe to produce, store and transport. Now, to give you an idea, Air Liquide operates a network of around about 900 kilometres of pipework in Northern Europe, transporting hydrogen from all the way down from Rotterdam down to the French border, which has been operating with systems like that built up over a period of nearly 40 years with an exemplary safety track record. Something that's perhaps not really understood, that how much it is used in industry has been commonly applied. And critically, as you'll see, particularly I think Graham will talk about, is it provides an excellent energy buffer. provides an opportunity to overcome intermittency and deliver grid balancing. So combining the two, hydrogen and fuel cells, you can reduce CO2 emissions. There are a number of benefits in terms of alleviation of fuel poverty, environmental benefits we've talked to. So just moving forwards in terms of some of those questions that people ask in terms of where does the hydrogen come from. Even if we take hydrogen from some of the existing industrial sources, which is just our starting point and not the view of where we would want to go. If you look at it for, say, a petrol engine, you might be seeing something like in total of around 160, 180 grams per kilometre from fuel production and from vehicle emissions. For hydrogen from a fuel cell, there are 0 emissions at the tailpipe, and if it came from a carbon source, there might be about 90 grams per kilometre in terms of emissions. So already you're showing significant benefit from where you are now. And the vision is that those sources which currently use carbon would become decarbonised, that there will be other sources coming which actually have 0 footprint. So essentially you start from an improved position and the view is to head in an ever-improving direction. Same goes if you look at something for mobile applications. If you use a genset working off petrol or diesel effectively can emit around 37 tonnes per annum in CO2 emissions. You're at 2.8 if you use hydrogen from existing sources, and if you take it from improved sources, you will actually eliminate that altogether. So as we've talked about, we're in a situation now where we've gone from pre-commercial technologies where they're high cost with demonstration projects, production facilities are becoming more fully loaded, and we're actually transiting to a situation where the economies of scale are improving and we're moving forward to effectively applications which are being applied in the field now, offering 0 emissions, high efficiency and a real alternative with stationary applications such as data-aware backup, grid balancing potentially, mobile applications, we've talked about forklift trucks, transport and road signage applications where they can work. So these are areas where now there are units running and we're operating on effectively a commercial basis where you have continuous units from 1 to 2 kilowatts offering 10,000 hours of continuous supply, temporary power supply units from 1 to 2 on 3 to 12 month campaigns, hybrid applications with 1 to 3, and some long-term mobile ones in the 1 to 10 kilowatt area. Clearly going forwards there's a key opportunity as well to decarbonise transport. Fuel cell electric vehicles are a key part of the potential mix going forwards. As we've indicated, even with current fossil fuels there's a significant saving, and moving forwards that would move to 0 emissions. And talking about where we can go, we can talk about electrolysis of water using electricity generated by wind, nuclear or other green technologies, biomass gasification technologies, and also capture and storage of carbon dioxide from existing steam methane reformers. And our company is proposing at the moment a project in Rotterdam which will capture the CO2 from a methane reformer in Rotterdam and store that in the North Sea. Studies by McKinsey have stated that the cost of developing a hydrogen refuelling infrastructure will be comparable with other technologies. What's needed really is to move that forward is a vision, and that's where UK Hydrogen Mobility comes in. This has been launched by Department of Business Innovation and Skills. It's a programme really to bring across industry and government with a number of bodies in, and there's an investment to support to drive that. So it's a cross-body drive forward to create a vision. The aim is to create a template to see how do you ensure that you bring the vehicles, the fuel cell or the refuelling infrastructure together in a coherent format, or in a form that's actually financeable. And that project is moving forward with a number of partner companies, and there's further updates will be expected late this year, early next year. Moving on to the question of standards, one of the areas where, again, UK HFCA has developed forward is to develop an initiative with the BCJ. BCJ is the British Compressed Gas Association with a mission to ensure safety and handling in use and transportation of industrial gases, which have a number of respective publications. There's close links between the two, but also proactive involvement with government, and BCJ itself has a number of codes of practice listed in terms of HSE references and UK government legislation. The mission of the BCJ is safety. It was established in 1904 and it's been operating as BCJ since 71 with about 73 members and growing, with some 70 publications in there. But essentially what it is, it's a cross-industry view to actually provide safe standards. And we talked about the fact that how hydrogen has been operated and used commonly with no incidents and safe operation. This is all what this is about, is actually having a commonality of view. BCJ earlier this year, based on the cooperation with UK FCA, formed a partnership with a number of bodies looking at what we're called TSC9, so it's a technical subcommittee. The focus on that is hydrogen in particular, but also looking at other gaseous fuels. There's an involvement with BSI standards to take the BSI standards and look at where they are. And there's been particular discussion with HSE in terms of the appropriateness of design of infrastructure for gaseous and refuelling and filling stations. Take the example of the fact that if you put a fueling station into a local council area, at the moment you've got the issue for the people putting the facilities in. There are a number of international standards, but there's no clear code of practice to walk you through how to do it. If you're the planning officer, you've not seen one of these things before, there's no clear guidance on how to do it. So you run into a situation where there's some actual barriers to actually implementation, and clearly what we want to do is ensure that things are done consistently in a format there. So the whole purpose of what's being developed and acknowledged by HSE as a requirement and by planners is a code of practice for installation, so that when you do your fuel cell installation, there's a kind of step-by-step view that everyone's got to see what should be covered, how it should be approached, how the planning can be undertaken, and how the installation can be put in place safely with appropriate separation distances into the right kind of environment. That process is ongoing, and the first drafts of those are being developed now, and we expect that there should be something due for publication early part of next year, which actually puts us ahead of a number of other countries. I was talking with colleagues in France and talking about forklift truck installations recently, and they've got the same challenges across Europe, is that they're seeing where there are issues associated with putting these types of installation in and how do you move that forward. The same goes with standards in terms of purity of hydrogen required for those. So in summary, we can see that hydrogen installations are transitioning now from demonstration projects to economic and repeated business. There's a large number of companies now that are loading, and it's actually putting the technology forward into the marketplace. And then moving forward to 2015 and beyond, we need to have a clear understanding how this should be installed, interfaced with the environment, more and more moving from industrial environment to actually public spaces as well. And those codes of practices have been developed by the industrial professionals within the UK FCA, across the BCAJ, across the companies you can see presenting to you, who are taking a very serious view in terms of both providing reliable technology, but also economic technology and safe technology. Okay. Thank you very much.